Lesson 7.5, Video 1. Now we're going to talk about factoring a difference of two squares. Now it's important to emphasize difference, meaning that we have subtraction. And also meaning two squares means they are both rootable. If that's a word, I'm going to use it anyway. But you can take the root of both of them. Okay, for example, a 2 would not be rootable, but a 4 would be. A 5 would not be rootable, but a 9 would be. An x squared would be rootable, and things like that. So you have to have two terms that are rootable, and they have to be subtracted from each other. Now, to do so, let's remember something important about conjugates. Now, if you remember, if I have x plus 1 times x minus 1, those are considered conjugates, which means they're almost exactly the same, except one's addition and one is subtraction here. Now, what happens, if we remember, when we multiply conjugates? Well, if we FOIL, if you remember, if we FOIL, the outside and inside factors are going to be opposite each other, and they're going to cancel each other out. So let's see what happens here. If I FOIL, first times first gives us x squared, outside gives us negative x, inside gives us plus x, and last gives us negative 1. So these two terms cancel each other out, and we're left with x squared minus 1. Now that's one direction, that's distributing. Now today we're going to talk about going this way. Now notice, x squared is rootable. I can root x squared and I get x. 1 is rootable. The root of 1 is 1. And you have a difference. And look how your solution would be if we go that direction. Our x squared is created from those two, and our 1 is created from those two. So if we look at our first one, and we ask ourselves, is each term rootable? And yes, I can root 16 and I can root b squared. I can root 9 and I can root b squared. So that means we are going to be able to root this, or factor this. So if you remember, first times first has to be equal to that. So I'm going to root both of those, or I'm going to take the root of 16v squared, The root of 16v squared is 4v. And I write that in the first position. If I multiply those together, first times first is 16v squared. And then I look at my second piece, and that's a result of the last terms being multiplied. And the root of 9 is 3, and the root of b squared is b. Now, these have to be conjugates. So one's going to be plus, and one's going to be minus. And that allows us then, if we went backwards and FOILed, that because they're conjugates, you would have no middle term. Alright, so something that's very interesting. Now, notice it's not a trinomial. It doesn't have four or more terms, so you can't factor by grouping. It's just two terms. And that's the neat thing about it. Now, to do this, if we asked ourselves this question, are they both rootable terms? Well, 27h cubed is not a rootable term. 3h is not rootable. But we want to get comfortable saying, you know what? I do notice that they are both factorable by 3. 3 goes into both. And they both have an h. So we kind of go back to day one of factoring and say, well, what do they have in common? And if we do that, if I divide 27h cubed by 3h, I get 9h squared. Dividing 3h by 3h, I get 1. And what's interesting is, after we factor that out, we actually do end up with a difference of two squares. So we will have 3h, and we can root that binomial because they are a difference of two squares. And we take the first term and we root that, and we write that in the first position of each bracket, of each parentheses. And I do the same with our second term. We get 1 and 1. But again, they must be conjugates, so one is addition and one is subtraction. And that is considered the finished factored form. And this ends Lesson 7.5, Video 1.